Thank you so much, Sneh and Landeka. Good morning, UKZN students and staff. Welcome to the Sasol Industry Talk hosted by the School of Engineering. My name is Leena Rajpal, and I'm the public representative for the College of Agriculture, Engineering and Science. I want to thank you all for joining us today. And most importantly, I want to thank our guests from Sasol who've taken the time to present to our students and staff. I would now just like to mention a few house rules for the program. Firstly, the event is recorded. In terms of complying with the POPIA Act, kindly note that we will use the information for publishing purposes. Should you not want your information to be published for the purposes stated above, kindly send me your concerns to rajpal@ukzn.ac.za. During the course of the event, all attendees will be muted with their videos switched off. If you have any questions during the presentation, kindly post them in the chat box facility where it will be answered. During the Q&A session, the presenter will give you a chance to ask your questions. Please raise your hand so the tech person can identify you and allow to unmute and pose your questions to the presenter. If by any chance attendees interfere with the presentations, we will note your details and remove you from the event. Finally, the recordings will be emailed to all attendees present and will be posted on the CAES website. I would now like to hand over to Professor David Lokhat, who is the academic leader for chemical engineering. Thank you.
Thank you so much, Leena, for that introduction. Students, colleagues, thank you so much for taking some time to join the industry talk this afternoon. This is part of a series of industry talks aimed at exposing students to industry, peeking behind the curtain, seeing exactly what they are doing, and then also illuminating some opportunities for graduate employment and so forth. We are really privileged to have two speakers from Sasol joining us here today to give us a little bit of an understanding of what the company is currently working on, and then also some of the bursary and graduate employment opportunities available at Sasol. It's a two-part program. Our first speaker today is Mr. Martin Peet. He's a senior specialist in process safety. He's been working at Sasol since 1998 and has spent most of his time working with the process safety team there. He's got extensive experience in HAZOP facilitation, for instance, and has represented the company on many projects with various engineering houses around the world. And today he's just going to give us a little bit of a taste of what he's doing, and hopefully the students gathered here today are going to really enjoy the presentation. I'm now going to hand over to Martin. Martin, can you take over? Over to you.
Good morning, good afternoon, everybody. It's just turned midday. It's Martin speaking. You should be able to see my picture there. And if I can get the technology right, I'm going to share my screen with you. Here we go. I click the button, share. You have to excuse me, I'm a bit of a technology dinosaur. Great, so you should see a presentation with a Sasol presentation sheet on. So please let me know if you cannot see it. It says I'm screen sharing. So it's my honor and my privilege this morning to represent Sasol and to be amongst you and sharing with you. So I'm looking forward to it. And just a bit of an overview what we're going to do. I'm passionate about process safety, so I will talk quickly. We've only got half an hour together, and sometimes I tend to run off at a tangent because, as I say, I get passionate about things. So it's best to be passionate, I think, and embrace the subject rather than just read from a pre-prepared set of notes. So basically what we're going to talk about is a bit of a sandwich. So we start off with a slice of bread, just an overview, a bit of an introduction, purpose of what are we trying to achieve today. And I want you to ask yourself, what am I doing? Where do you see yourself in the future if you are going to be practicing chemical engineering? And I'll give you a few options there. because that tells you how you're going to interact and interface with process safety. Then we're going to get onto the meat of the sandwich. We're going to say, what is process safety not, first of all? And then we'll say, okay, having decided what process safety is not, what is process safety? And then my favorite two words as a HAZOP facilitator, so what? And my other favorite phrase is what if? Okay, so what if and so what? Then we're going to talk about a chronic sense of unease. You'll see that term is in inverted commas. It's a term from the ICME. And so if you can get onto the ICME websites from the UK and their government organization, the Health and Safety Executive, lots of good information there. Also on the American Chemical Engineers website, lots of good videos as well. Then to finish off the meat, we'll talk a bit about bare awareness and bare necessities, and then we'll finish with a concluding message as part of the final slice of bread on the sandwich. And that's important to put this into perspective when we're doing talking about process safety. Oh dear, I hope you can still hear me. Because I'm based in capital projects, so I'm not based in operations. So I'm based in capital projects, and I'll expand upon that in a minute. I'm a chemical engineer by qualification, but specializing in process safety. And I graduated from the University of Manchester Institute of Science and Technology in 1984. I enjoy a good coffee, and I'm a big football fan, but my team is not Manchester United or Manchester City for that matter. Great, let's move on. So the purpose of this presentation is, what I want to do is give you something that I didn't get when I was at university. Oops, sorry, I'm trying to move things around so I can see the screen. And is that just a bit of an insight into what is process safety? And I think as an industry, the chemical process industries is still learning that a bit, because the big problem with the word process safety, or the phrase process safety, it's got the S word in. The S word is safety. So people have a typical stereotypical mindset of what safety is. And so they just think there's a safety department, and really there's not. There's a process safety team, and there's other aspects of safety. So that's why we're going to say what process safety is not. So I'd like to give you impart you an understanding of what process safety is, what it is not, and emphasize the key role of process safety in the world of chemical engineering. So if you don't like process safety and you think, oh, that's not for me, I'm not going to get involved in process safety, I've got bad news for you. You will be involved in process safety inherently, just like you will be involved in financial aspects. You can't just go spending money or over budget. You might have a financial department, but you still have a finger in the pie for financial management. Okay, you will always have process safety there. It's an inherent part of your job. Great, and I'd like to leave you with a bit of an analogy so that you can recall what process safety is and why it is important. So I'm really trying to get into your hearts today, not so much head work, head knowledge, but heart knowledge. Okay, some heart massage, some open heart surgery. And I want you to ask yourselves, what am I going to be doing? So this is a rhetorical question. What am I doing? So the type of work that you do as a chemical engineer could influence the scope and application and the relevance of process safety. So let's dwell on this. So this is a bit of an insight into potential careers maybe as well. You could be involved in operations. So I mean, hands-on, shifting spanner in your hand, overalls, gloves, hard hat, safety glasses and boots, and walking out, operating the plant. And that's what happened to me when I first started working in the base metal refinery. I came over, I had a piece of paper in my hand. Hey guys, I'm a chemical engineer and I like football. And they said, here's some overalls, here's a shifting spanner, and go and disappear for 18 months and do your shift training. And I did that, and I got to see what a motor looked like and a pump, what it was like to flush a pump, all these things I'd read in textbooks at university. I then got to actually experience. And I think what has historically happened in operations is people have been employed at a relatively low level in operations. And as time has gone on, those people have progressed into more senior positions, into the supervision. You see the second bullet point is operations supervision. And I think the industry is trying to get away from that approach. They're increasing the academic requirements for process operations people, so that you actually come in with some sort of tertiary education just to be able to run the plant, because these plants are dangerous. We need people that understand the process and what is going on. So you could be operating the plant, or the second bullet point, you could have progressed to a position where you're supervising others that are operating the plant, or you could even be managing the plant. So somebody comes in, you're the manager, you come in the morning, you check your production, you check the status, your health of your plant, and you report back. You are held accountable for the performance of that plant that you are managing. And obviously you cannot manage the plant unless you know what is going on, both technically and experientially in that plant. Alternatively, one common role is the operations technical support. So you're not actually operating the plant. You might have done a bit of training, you know what is going on, but that manager comes in the morning, says, guys, we're not producing. The last week we haven't produced and there's a bottleneck in the plant. He's going to look you in the eye, Mr. Operation or Mrs. Operations Technical Support, say, sort this problem out for me. Why are we getting a bottleneck in a certain part of the plant? Go and do some troubleshooting. Why is the heat exchanger fouling up, for example? Or they might say the plant, our feed plant is changing its catalyst. It can now give us much better quality feed, but we need to debottleneck our plant. So a lot of the work the operational technical support person does is troubleshooting, but also small projects. And also a very key term in process safety is management of change, MOC. Change is risk, so we need to manage changes. So this operations technical support person is saying, I think we can solve the problem by doing this, this, and this, but then we've got to make sure that we do it safely and we don't make a plan late on a Friday night, 2 o'clock in the morning, and we start doing things that we should not be doing. We must manage change. Okay, then the background that I come from is the projects department. So I don't go to work in the operations. I don't work in the plant. I can go into the plant if I want. I have no operations experience at Sasol. My experience is entirely on capital projects. So I work in an office environment and I work in 2 dimensions. I work on piping and instrumentation diagrams. So that's a phase of the project where I'm involved. And then finally, my colleague who's liaison with UKZN is Pragna. She's with us this morning. She's more involved in the research and development and the concept development. So before a project comes to my team, Pragna might have developed a concept or developed a new catalyst at the R&D laboratories that we can use. And she will also be exposed to process safety. Okay, so there's various different types of careers there, and obviously process safety is mainly involved in the operations, and in my case I have to design process safety and put process safety challenges in place to ensure that I give the operation colleagues a good project that is safe. So ask yourselves, what am I going to be doing? And that will determine your level of exposure to process safety. But we still haven't said what is process safety. So what is process safety not? Well, process safety is not occupational safety. Remember I said we can be guilty of using this word safety as a very generic term. So historically we associated with occupational safety, and occupational safety is like a dog. Dogs are all around us. We must manage dogs every day. If I go out for a run in my street and the next door neighbor's gate is open, the little dog comes out and starts yap, 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 and it wants to bite my ankles. So I try and give it a little kick if I can. And that's all very well and good until the dog looks like this dog in the picture. Then it's a different kettle of fish, because this dog wants to bite me. And you can see this is a Sasol dog. He's very well built up and very muscular and used to getting his own way. Okay, so we have to be careful. So dogs are all around us and we must manage dogs all the time. Occupational safety is all around us. It's not a Sasol thing. You get occupational safety risks at home, at the university, in the bank, in the local shop that you go to. Occupational safety is all around us and we must manage it all of the time. So it's not specific to industry, and occupational safety is anything that you might be exposed to when you go about your normal job. So you might be at home fixing the roof and you fall off the ladder. That's an occupational safety incident. Okay, you might have to wear gloves when you're drilling. Okay, that's an occupational safety control. So anything that you get involved in could lead to an occupational safety incident, getting electrocuted maybe when you're working on a switchboard. And you know, when a dog bites you, you know about it. Okay, similarly, if you have an incident, you have an accident at work, you know about it. You know, at such and such a time, at 12:15 on the 13th of September 2022, I fell down the steps and I twisted my ankle. You know, there and then you've had an accident. Okay. And occupational safety can be very emotive, because if I tell you, if you get some of that acid in your eye, you're going to lose your eyesight. It's gone in a second. Okay. You don't get a second issue of eyes. Your eyesight is gone. Okay. So it can be very emotive. Okay. So process safety is not occupational safety. It's not a dog. Neither is it occupational hygiene. Okay, and occupational hygiene, I say, it's like a mosquito. So what does a mosquito do? It stresses us. Okay, so you can see from my hairstyle, I'm a bit lacking up top here, and mosquitoes stress me when I'm sleeping at night, just when you're falling asleep, and you feel it on your head, and you're slapping this mosquito. Okay, and maybe you get the mosquito and you get covered in blood and stuff like that. But for me, then every 2 minutes, I can feel this mosquito on me because it has stressed me. And occupational hygiene is about things in life that stress our physiological well-being. So things like loud noise stress our hearing. Bad light can stress our eyesight. Dust in the air can stress our lungs. Heat and humidity can stress us in the way that we work. So all these things are stressors. And again, mosquitoes are all around us. Occupational hygiene is all around us. I can go to work and I can sit in the compressor house and I can be exposed to 100 decibels of noise. Or I can sit with my earphones in listening to doof music at 100 decibels. The noise, the ears don't know, hang on, compressor is occupational, that's going to make me deaf, but the doof music isn't going to make you deaf. No, it's the same effect all around. It's stressing my physiological well-being. Okay, and mosquitoes are all around us, so we must manage it at home, we must manage it at work, and we must manage it wherever we are. Okay, the difference between the mosquito and the dog is sometimes a mosquito bites you and you don't realize it. So I can be exposed to noise, those decibels, and I go into the compressor house, I don't wear my hearing protection, and I get exposed to noise. I come back to work the next day, my hearing's fine. Exposed again to noise, next week, my hearing's fine. Next month, my hearing's fine. Until one day, in a couple of years' time, you're watching the TV and the rest of the family say, turn the television down, it's so loud. And you say, no, I can hardly hear it. And then you realize your hearing has started to get lost and you've lost your hearing. Okay, so occupational hygiene things tend to affect you in a more longer term. So it's difficult to get emotional and emotive about occupational hygiene. You can't put that exact date on when the incident occurred like you can with a dog bite. So process safety is not a dog, not occupational safety, it's not a mosquito. Process safety is a bear in a cage. Okay, look at this nice friendly bear here. And process safety is about the loss of containment of hazardous substances. Okay. So first of all, bears in cages are not all around us. Dogs are, mosquitoes are, but bears in cages are not all around us. Okay, so you have to go somewhere special to see a bear in the cage. So you have to go somewhere special to get hazardous substances. So you're going to go to a Sasol. Okay, so whereas we have to manage dogs and mosquitoes all the time, process safety is very much industry-based on that hazardous chemical industry. Yes, maybe at home I've got a cylinder of LPG for the gas brine. Okay, but that's not what we're talking about. We're talking about large inventories of hazardous substances. And we need to prevent that hazardous substance from getting out of the cage. The cage could be a pipeline, it could be a pressure vessel, it could be a tank. And you might say, well, let's practice the principles of inherent safety. If I don't want that bear to get me, maybe I should just stay away. Don't go and see the bear in the cage. In fact, let's not have any bears in cages. And that's fine. I can solve Sasol's process safety problems at the drop of the hat. We just pull the plug out, no more Sasol, no more process safety, no more bears in the cage. But unfortunately, the bear is our business and it makes us money, and we would not be very popular with the general public. There'd be a shortage of diesel, oil, and hydrocarbons. So we have to keep that bear in the cage and we have to manage the risks. But you know what? My last bullet point there, bear in the cage is safe. I can go up to the cage and I can rattle the bars and I can really make this bear mad. Okay, I can dangle food in front of him. He slavers at the mouth. He wants to get me. He wants to kill Martin, but he can't get me. He's in the cage. And I often tell my students and the young engineers there's more chance of me dying in a road accident on the way back home to Johannesburg from Secunda or Sasolburg than there is of being involved in an industrial accident on the Sasol site. Okay, because the bear is safe. We can up the pressure, we can increase the flow rate, we can increase the temperature, put different catalyst in. It's fine, the bear can't get us because he's in the cage. So remember I said my favorite 2 words. This sums up process safety. So what? If Martin says the bear's in the cage, maybe he should spend his time talking and preaching about road safety and not process safety. The trouble is, what if the bear gets out? The bear kills people and it's got the potential for multiple fatalities. When process safety, there's a loss of containment of hazardous substances. It's got the potential, either it could be toxic, it could be flammable and cause a pool fire, or it could form a vapor cloud and it could go bang and we could have a big explosion. So that's the danger with process safety, that it's about the potential for multiple fatalities. And you know, from this picture, they say you don't have to run faster than the bear. Don't worry about the bear getting you. You don't have to run faster than that bear. You just have to run faster than one of the other 2 guys. And you know the bear will get them before they get you. Right. So here's this thing I said, a chronic sense of unease. This is a risk graph. Okay. So risk, we can expect risk is a function of consequence and likelihood. So it's the likelihood of a certain consequence being realized. And often we talk about fatalities. Okay. So obviously the bottom left-hand side of the graph is good because there's a low likelihood of an incident happening and there's a low consequence anyway. So maybe once 1,000 years you get a cut finger. That's nothing, okay? But if we said high consequences and we went to the top right, so maybe every day there could be a fatality. That's not a good probability. So George Orwell used to say 4 legs good, 2 legs bad. We say bottom left good, top right bad. Okay. And occupational safety incidents, remember the dog bites that I talked about? They're typically not fatalities, although they could result in fatalities. You could fall off a scaffold or a scaffold could collapse, but typically those are more minor injuries. There are high number of them happening quite often, but they're very low consequence. And what's happened, Sasol has a very good occupational safety record because over the years we've investigated these incidents. There's been so many of them. We've actually moved occupational safety incidents from the bottom right quadrant to the bottom left quadrant. Okay, because we've been reactive, we've investigated them, we've realized the only way to reduce our occupational safety incidents is to be more proactive with job task risk assessments. But process safety is a different baby altogether. Process safety is in the top left here, low likelihood. These don't happen very often, but when they do, they've got the potential for multiple fatalities. We cannot wait for a process safety incident to happen and then investigate it, and hopefully it won't happen again. That's too late. We've killed people. So we need to be proactive in how we manage our process safety in order to prevent the bear getting out of the cage. So that's what a process safety system is all about. Is where are you going to focus to prevent the bear getting out of the cage and having a process safety incident? So this is a very powerful graph, and you'll come across it a lot. Risk is a function of consequence and likelihood. Right. So now some bear awareness. How does the bear get out of the cage? Okay, if Martin says process safety, we've got to keep the bear out of the cage. How on earth did this bear get out of the cage in the first place? And you must know your bear. Okay, so if you've got a tank load of water effluent and you've got a tank load of corrosive hydrocarbons, you're going to spend more of your time looking at the corrosive hydrocarbons that could catch fire and a loss of containment than you are on the aqueous effluent. Okay, and sure, you might not want to bath the baby in the aqueous effluent, but it's not as dangerous as the hydrocarbons. So you've got to know your inherent dangers. Some bears are bigger than others. Okay, and you might have heard of a guy called Stephen Covey. He wrote a book called 7 Habits of Highly Successful Managers or something like that. So it's worth a read. but I've got 7 habits of highly dangerous bears. Okay, so I've got about 10 minutes left just to finish off here. And so Stephen Covey got this idea from me, okay, the 7 habits, and he still owes me the money for it. Okay, so if you do see him, you read his book, just bear that in mind. Okay, so first of all, the bear in the cage. This bear is angry. I told you about the bear pulling on the pipes, on the bars of the cage, or pressurizing the pipeline, pressurizing the pressure vessel. We must design the cage. And there's a breed of people out there who aren't good enough to be chemical engineers. They're called mechanical engineers. So they need to design the cage for us. We're going to tell them, how big is this bear? What is the vapor pressure? What are we going to operate our plant at? And then Mr. or Mrs. Mechanical must go away and design that cage for us. So when we increase the catalyst, when we increase the temperature, when the pressure deviates, the bear cannot get out. Okay, so the cage integrity is important. But a cage is a cage. It's a piece of mechanical equipment. I've just used the word integrity. That's very important. So every time the bear pulls on the bars or we pressurize the process, we stress this cage. Every time there's a bit of corrosion, the cage might get weaker. The integrity might be compromised. So now the second bullet point here is we're looking at the integrity of the cage, and we're introducing the concept of life cycle. We must design the cage, but the projects team do that. But then the operations guys must maintain that cage. Okay, so they must maintain the cage so that over the life cycle of the cage, its integrity is maintained. Then we get locks. You know, these bears are clever. So you get a lock on the door of the cage because there's a door. You can't just bolt up the cage and never go in there. So there is a door on the side of the cage. And if we're not careful, this clever bear is going to lift the latch and get out. So we have to put locks on the cage. So we have what we call interlocks or trip systems, very much part of the process design. The best way to understand the difference between the trip system and your normal operations is, let me give you an example, is if you have driven today, or your parents are driving, or you've come to varsity today because you're driving, I could say to you guys, how do you know your car ignition is working? You can say, oh, Martin, you know, I've driven here, the car ignition must be working. The ignition is part of the operating system of your car. Okay. Now I might say to you, do you know if your windscreen wipers are working? Well, they worked a couple of months ago when we last had rain in Joburg. My wipers were working, but I must admit I haven't checked them today. Okay. So the wipers are not an essential part of the operating system of your car, but you do need them if something goes wrong, and they better work when you need them. So we have an operating system in the plant. So it might be a level controller, controlling the level, controlling a valve that opens and closes to control the level at a set point in a tank. And my job is to ask the question, what if, so what? What if that level controller fails? So what? So now it fails and the tank fills up. And in the background, we have a trip, something that's not part of the operating system. It's a high level trip. It's independent of the level controller, and it trips the plant, and it trips a separate valve closed to prevent the tank from overflowing. So it's an independent trip. And that's what we call an interlock. Okay, it's independent of the operating system, and it backs up the operating system, but it's only used very rarely. It's not part of the everyday process. If I didn't tell you, you wouldn't know it was there until the day you need it, like your wipers, and then it better work. So we need to design those interlocks to give us the backup from process safety, what can go wrong. And just like the cage, we also need to maintain them. It's no good having the windscreen wipers and they sit there for 3 years, the state-of-the-art windscreen wipers, but they're never maintained. When you need them, they don't work. The 5th bullet point is don't feed the bear. Because what happens when you feed the bear? You've designed the cage, you've got all your interlocks, you've got people doing maintenance left, right, and center, and then you feed the bear. And what happens when you feed the bear gets bigger and the bear gets stronger. And tomorrow, when the bear pulls on the bars of the cage, that cage that was designed for little bear is no longer strong enough to contain big bear. And this is all the thing I told you earlier about management of change. Change is risk, and the key thing in process safety is managing change, and you might be involved in that in your careers. Okay, so feeding the bear is changing the process, where we debottleneck the process to get more temperature, more volume, more pressure in there. We have to be careful if we feed the bear, and often our hearts aligned with good intents. Often incidents you can find the person's heart, the person's intent was very good, very right to try and solve a problem, but they didn't give it enough thought. So that's where process safety comes in. You come up with your design, you say, this is my design, this is the bottleneck I'm trying to resolve, this is the problem I'm trying to resolve. Then it comes to process safety. So what? What if? What can go wrong? So this slide, what if, so what? That sums up process safety. Okay. So if you want to know if you're doing a design, as I say, you should be looking at that and saying, so what if, trying to anticipate the process safety outcomes. Then the zookeeper, this is the interface between the dog and the bear in the cage. It's the interface between occupational safety and process safety, person and the process. Because now we've got this cage, we designed the cage, we've maintained it, we've got a big file of management of change documents, getting authorization, getting Martin involved, says us, so what? And then we do some maintenance on the cage. The zookeeper goes in the cage and he walks out and leaves the door open. The zookeeper says, the bear says, when we let the bear back in the cage, says, thank you very much, door is open, I'm going to go and kill somebody. Because the bear likes to get out of the cage. Have you ever seen a pipeline of chlorine when the chlorine pipeline breaks and the chlorine stays in the pipe? No. Okay, the bear wants to get out of the cage. So we have to manage that interface between people and the process. So we need to train people. So we don't train people how to change a pump. That's the artisan's job. The artisan knows how to change a pump, but we do tell the artisan, hang on, Mr. Artisan, that pump has got water in it. That pump has got hydrocarbons. This one is more dangerous. So we need to explain to people what the dangers are. Training permit to work is a document that gives permission from the process team for the maintenance team to do work. So permit to work is a key thing. And then operating procedures are very important as well. So you'll often find there's a lot of bureaucracy in process safety, but for a very good reason. Then finally, just as we wind up, the bear is dead. Long live the bear. What on earth does Martin mean here? Okay, and particularly relevant, we've just seen the Queen Elizabeth die. So we say the Queen is dead, long live the King. That's where this quote comes from. The bear is dead, long live the bear. So what happens is often we decide to decommission a plant and we mothball it. We say no longer do we need this process? So we take all the hydrocarbons out, we clean the plant. It's no longer dangerous. It's inherently safe. No more bear in the cage. Phew. And then what do? We need to passivate it. So we fill it with nitrogen to stop it from corroding in case we need to use it in the future. Nitrogen is deadly. It's 79% of air. So I think, nitrogen is harmless. 79% of air. You can't smell it. You can't see it. And the number of incidents that occur due to people being overcome with nitrogen fumes is, just look at the databases, as I say, from the UK or the US Institutes of Chemical Engineers. And also, if the zookeeper needs to get into that cage, we've got to do something with the bear. Even if the bear is not dead, we've got to isolate that bear, put him in another cage and make sure it's safe, or chain the bear up so he doesn't get the zookeeper. So the bear is dead, long live the bear. It's about other hazards that we might introduce, so we don't need to get complacent, and also isolation as well. And I just want to go back here. This slide here, the top title of this slide is a chronic sense of unease. So what I omitted to tell you is that you might have a very good occupational safety record. You might be good at hats and gloves and people falling off ladders and not getting electrocuted, just like Sasol is. Very good. We move this bottom right occupational safety down to the left. But these are not related. Okay, this is a very powerful graph. The causes of process safety incidents are not related to occupational safety incidents. So we cannot afford to get complacent. Sasol cannot say, we haven't hurt anybody, we've had no broken fingers, no broken arms, no people falling off scaffolding, therefore we're not going to have a process safety incident. These are different things. Okay, and I can show you a video of something that happened at BP, Texas in 2005. 15 people were killed. They just come away from a coffee and cake session, or if you like, the equivalent to a braai, where they were celebrating a safety achievement, celebrating an occupational safety achievement. They went back into their prefabricated offices. A plant was starting up nearby. There was a loss of containment. It went bang, and 15 people got killed in those offices, having just come from a safety event. So these two are not related. And if we're in the process safety industry or chemicals business, hazardous chemicals business, we need this chronic sense of unease. What is chronic? I take medication for cholesterol. And that's chronic medication, something that's there all the time. So we need to have this sense of unease. We need to be on our toes all of the time. We cannot afford to get complacent. Okay, it's inherent in our business, it's inherent in our industry, and we need to manage it. That's what we use process safety for. Very quickly then, we have a process safety management system. So you will find companies have safety management systems, and I'm winding up. This is my last slide, apart from a brief summary. And they will say you must wear hats and gloves. You must check your electrical equipment. You must check your ladders. Okay, all those are important, but checking a ladder isn't going to stop you from having a loss of containment. Remember, I said the causes are different. So what this is a process safety management system. This is putting the M at the end of process safety management. Okay. And it's about what things do you need to do better? What things do you need to excel at if you're going to prevent the bear getting in the cage? And you better take this to the next level. So here are some of the things we talked about already. Process safety information. This is your baseline, the quality of your P&IDs. Your process hazard analysis. This is where I come in. So if I'm on a project, I'll be involved in this hazard analysis. So what? What if? What can go wrong? How can we get deviations from design intent? So this is where the HAZOP fits in. We talked about the zookeeper, the human process interface, safe operating procedures I mentioned, training I mentioned, work permits, there we are, number 9. Feeding the bear, number 10, management of change. And the last one I'll just dwell on because we're running out of time is maintenance integrity. Are we maintaining our critical plant to keep the bear in the cage? So this is typical of a process safety management system. And as I say, we need to excel in these areas and really go to the extra level if we're going to prevent the bear getting out of the cage. You can also see number 12 is more contingent. So number 12 is about emergency planning and response. It's not about preventing the bear getting out of the cage. That's saying if the bear gets out of the cage, have you got the right resources to tackle the bear? Then finally, in conclusion then, I want to say, message I want to get over to you. So process safety is about the bear getting out of the cage. It is specific to hazardous chemical industries. Why are we so worried about it? Because it's multiple fatalities. We don't like, human society does not like multiple fatalities. If I told you next year, 2023, every day there'll be a road accident and every day one person will get killed. At the end of the year, 365 people will be dead on our roads. Or I could tell you one year, next year, 2023, there'll be one plane crash. And in that plane crash, all 365 people on board will be killed. So you've got two scenarios, both result in the same impact over the year, but which one makes the news headlines? Okay, we have an aversion to multiple fatalities. It's not right. Okay, please, as you go on with your careers, don't abdicate to the process safety team. Typically, the process safety team is a small team. We are there to enable line managers, operations, project teams to ask those questions. What if? So what? But it doesn't mean to say, we say it's nothing to do with me. I don't want to be involved in process safety. It's like saying, I don't want to be involved in finance. Okay, you might have an accountant, but if the finances of your business aren't running well, you don't have a business. You're responsible for the finances as well. And above all, proceed with a sense of chronic unease. And there, I think my time is up. So Monica, Professor, I'd like to leave it there and hand back over to you for some questions, please.
Thank you so much, Martin. That was really great. I really enjoyed that, and I'm sure our students did as well. You've practically taught my course. I'm going to ask that we take some questions at the end of the session in the Q&A session that we've got coming up a little bit later. I'd like to also encourage the students that have attended today, use the Q&A function to drop any questions that you have on there as well. And we'll make sure to have a look at those during the Q&A session as well. Martin, I'm going to release you now for this period, and I'm now going to bring on the second speaker. That is Mrs. Monica Luwes, the manager for the Graduate Center and Development Programs at Sasol. She's been working at the Sasol Graduate Center for over 10 years and it's responsible for the bursary selection and placement of graduates within the Sasol organization. And she's going to be speaking to us about the timelines for the bursary program as well as graduate development programs. Monica, over to you.
Thank you very much, Prof. Martin, thank you very much for your insightful presentation. But can you please stop sharing, because on my side, I'm not allowed to share. They say it's one participant at a time.
I think I have stopped sharing. I've got a tablet that asks me if I want to
now,
share.
there I can share. Thank you. So, ladies and gentlemen, thank you very, very much for your time this morning. And thanks for Prachna, Leena, and UKZN for giving me this opportunity to have a discussion with you this morning. There, I'm on my last slide. So let me start from the beginning. So, I'm the manager for Sasol Graduate Center. So in the Graduate Center, we have two areas of responsibilities. The one is the bursary program, and the others is the development program. So how it works is we have different bursary programs with different aims, and then we have different development programs also with a different aim at the end of the day. So if you look at our bursary programs, we have a Sasol bursary program, we have a Sasol Foundation bursary program, a Sasol Energy bursary program, and then we have bursaries for people with disabilities. The Sasol bursary program is our feed stream for the skills that Sasol require for the Sasol of the future. And in Sasol Foundation, Sasol Energy, and in people with disabilities, we typically grow them, those bursary pools for skills for South Africa. So we look at the market and see what's required in South Africa in general. Then the development programs, we have one for engineers, one for scientists, we have one for our mining environments, and then we also have a technician development program. For the purpose of today, I'm going to give you information on the development programs for engineers and scientists. But if you have any questions on the mining environment or the technician development program, you are more than welcome to email me, and I would gladly share that information with you. So just in terms of, because I know you would like to know, where do we apply for these positions? The bursary programs, all of them are advertised on www.sasolbursaries.com. And I will also share a slide with the current opportunities that we have in the bursary program with you. Development programs are advertised on the career section of our Sasol portal. So if you are interested in a career in Sasol and you are not a bursar, but you would like to be made aware if something comes up, I strongly advise and urge you to go to the careers portal of the sasol.com and go and register your CV there. What happens then, every time a new position is loaded, then you get a notification to say, okay, we are advertising for engineers in training or for technicians in training. There might be other opportunities as well that you might be interested in. That's not necessarily a development program, but it's in line with your career aspiration. So please register your CV there. Then if I look at the Sasol Graduate Center value chain, our bursars, and talk about our Sasol bursaries, are a feed stream into our development programs. So we start with a planning process. That's to determine how many people do we need in Sasol at what stage. Then we do the recruitment and the selection, and we have a new bursar orientation. Every year we do a performance review or review of your academic results to see, are we continuing with the bursary or are we stopping that? Then we have students discussions. That's twice a year. It's virtually, where we just check in to see how it's going with the bursar as a person. Just because we have two formal discussions doesn't mean we don't engage with our bursars at other stages as well. And then we have VAC work where you come and you do a project at Sasol. Now, that we do for all the bursary programs, regardless whether you use Sasol Foundation, Sasol, or Sasol Energy Burses, that's for everyone. And then when we get to graduate placement, that's when you are placed after. I see there's hands raised. Is there a question?
It's okay, Monica. We'll take the questions just after your presentation.
Okay, perfect. So then when we start with graduate placement, that's placement once you have graduated your degree. That's for Sasol burses and for top-ups. So what's a top-up? I hope some of you have applied for our top-up opportunities that went out about a month ago. That's when we don't have enough burses in the Sasol pipeline to supply the needs of the business. So what happens there is there's new projects, the company grows, someone might have failed while they were a burser, and that's when we recruit fourth-year students to come in. And then once you're on the development program, there's an orientation where it's explained exactly how your training program is going to work. There's 6 monthly panel reviews, there's salary adjustments, and then you are placed upon completion of your training program. So that's just the value chain of how we work in the department. Then I want to go back to our bursaries for now. So what does a Sasol bursary include? It's the registration fees, it's tuition fees, it's book and pocket money, meal and accommodation, a one-stop computer and calculator allowance. And then we support psychosocially with students, discussions, workshop, and then our burses and our candidates on our development programs is also registered with our employee assistance program, which is done via Discovery. So if you need any help, they can also support. Then currently we have 2 bursary opportunities available. The one is our Sasol Foundation bursary applications is open until the 23rd of this month. That's for STEM, anything in science, technology, engineering, and mathematics. So if you're interested, please go and apply. If you go to sasolbursaries.com, you will see all the information is on there. Like I say, the closing date is the 23rd of the month. And then on the 18th of September, we also, there's a closing date for Sasol bursary program. So we had our bursary interviews in the July holiday period, but there's certain disciplines where we didn't get enough applicants, or we didn't make the numbers we need. And that's specifically chemical engineering, electronic engineering, cybersecurity postgraduate, and then mining engineering. So I guess most of you on this call is from the process chemical side. So if you're interested in a bursary, please go to our website. Like I say, there's 2 opportunities, and go and apply. You will see all the info and the criteria is on the website. Then I'm going to go back to our development program. So the development program is really there to help you to become a competent engineer after studying. So there's a few things that we look at when we develop such a program. So the one is standardized. All the graduate engineers and scientists entering Sasol will go through a formalized and structured development program tailored to each discipline, considering their geographical specificities. So that's really where, so a mechanical engineer and a chemical engineer will not have the same curriculum. A mechanical engineer in Sasol mining and one in operations will also not have the same training program. It's a standard for the environment they are in, but we make sure it's tailored for each discipline and for each specification. It's comprehensive. Entering graduates will be expected to exposed to all relevant areas within the business, with mandatory rotation being the key vehicle to achieve this, of which a minimum of 1 will be in operations. On the next slide, I will show you now the rotation to operation environment. It's competency driven. The program's effectiveness is determined by the competencies created in the entering graduates. Therefore, it includes regular assessment of graduates to steer and support the development. Every 6 months, as I mentioned in our value chain slide, and you'll see it on the next slide as well, our candidates go through a panel assessment where they are tested against the competencies for that specific 6 months. And that's also how they progress in their program. It's practice orientated. We believe by doing is how you actually learn. So 70% of the time is practical and the job experience, 20% is mentoring and coaching, and then 10% is formal classroom training. And then, yeah, it's aligned with business needs because we would like to train them to work in our operations. This is just a framework to illustrate what I've said now. So it's 3 years and 56 months. Normally, operations is the first year. It might slightly differ for the scientists, but the engineers. Operations is year 1. Year 2 is engineering on projects, and then year 3 is specialization. And then, like you see, every 6 months, there is an evaluation, a panel where you need to be evaluated. Then training, there's soft skills and technical skills, but that's in your curriculum. And then there's a whole lot of support from Sasol side to assist you in developing and meeting your competencies at the end of the day. And that's my story in a nutshell. I see there's questions, so I'd rather then answer your questions.
Thank you so much, Monica. We really appreciated that overview as well. I'd like to thank again Martin for that excellent presentation earlier and the talk on process safety, which is a particularly important area in terms of what we are doing as chemical engineers. And then, of course, Monica for coming in and giving us some information on the various opportunities that are available at Sasol. We've got a couple of questions that have come up on the chat. I'm thankful to the Sasol team for actually answering those for the students. If the students have any questions now, they can raise their hands and they'll be given an opportunity to ask those. I am seeing a couple of hands. Kanku?
Yes, thank you very much, Prof. I would like to know, today technology has advanced in new innovations. How Sasol do copy with new innovations that are relating to their process? Even if the research and development updates, but what happened to those ideas that Sasol has not come across with, but still hang on there in terms of novelty, but still very potential for the R&D at Sasol?
Thank you, Kanku. I think that question is related to innovation and uptake of new technologies at Sasol.
David, if
yes,
I can
Pragma?
try and attempt an answer there. Thank you, David.
Sure. Go ahead.
That is our that's the purpose of our research and technology department, is that we actually do scan out there what are the new innovations that we can consider to take into our process flow scheme and create new projects if it is viable. It's a very short answer, but I hope that answers your question.
Thank you so much, Pragna. Just for the purpose of the meeting as well, can you just please introduce yourself to the students?
Sorry. Let me just switch my camera on, I suppose, as well. There we go.
That's great.
I'm Pragna Rajara. I'm the senior manager at the research and technology department of Sasol, and that is precisely our purpose, is to scan out the new innovations, what is applicable to Sasol and how to bring it into the company. Thank you.
Thank you so much, Pragna. Thank you as well for introducing yourself and showing the students your face. You've been quietly sitting in the background, attending to the questions from the students. Thank you so much for that as well. Yeah. Okay, going back to the participants list, I'm not seeing any further hands coming up, but there are quite a number of questions that have come up on the chat. Feel free to look at them, answer them there, or if you feel it's necessary, then you can speak to them on the live platform as well.
Apologies, I'm just reading the question again because it's
That's
a
fine.
long question.
That's okay. We've got some time.
So, yeah, so we use the Odyssey assessment. So if we send your name through and the service provider comes back to us, they check how recently you have completed that assessment. And then those people, the service provider will tell us whether or not we can use it or not. Because if you have completed, there's a time lapse. So not on all psychometrics, but on the Odyssey. So it will really depend on when you have completed it, but they will pick it up if you have it done it before, because Odyssey, the one that we use, there's only one service provider in South Africa with one database.
Okay, thank you so much, Monica. I'm not sure if the other question was also covered, just regarding the graduate programs being open only to sponsored students, or
okay, so
otherwise?
no, I can answer that, no problem. So our bursars get preference on the graduate programs, but there are some times where we don't have enough bursars in the pipeline, as is the case this year, and then we market it for fourth-year students. So it's not necessarily only bursary students or sponsored students, it can be other students as well.
Thank you, Monica. And then the second part of that question was with regards to students with a straight BSc qualification, 3-year qualification, without an honors, will they be eligible for the graduate program?
No, the entry requirement for Sasol for our scientist training program is a 3-year BSc degree with an honors, and that's an entry requirement into our R&T space. So Tanya is also online. She's looking after our scientists. So I'm not sure if she wants to elaborate, but for us at Sasol, we are looking at a 4-year, 3-year BSc with an honors.
All right,
Thank you, Monica. Yes, I wanted to answer that one. Let me just also introduce myself. So I'm Tanya Hughes. I am the Capacity Development Manager at R&T. So I do look after the sciences that come in after their formal training. And Monica is 100% correct, is with a 3-year BSc, you would unfortunately not be eligible for an R&T position. You can, however, look out for a position in our routine labs as a chemist, but you would not be eligible for the graduate program or being placed in an R&T or process environment.
All right. Thank you so much, Tanya. That was a great introduction, and thank you for the answer as well. Martin, I saw a question in the chat box specifically for you, just regarding the process safety talk that you gave us, and whether there's sort of any possibility of overuse of instrumentation on a process plant. That you can maybe just come in and give us your thoughts on that.
Yes, we like instruments. Okay, so we have 2 types of control. We have a Spanish control that's operated by manually operated, and then Manuel's got a German cousin called Otto, and that's automatically operated. And obviously Otto tends to be more reliable than Manuel. People make mistakes, and the key here to the question, so I can't quite remember who asked the question, is independence. Okay, so when we design a system, it's very important to identify how does the system operate, and then that defines the design intent. So that belongs to the process engineers at a PFD. They will say, I want this plant to operate at a certain pressure, certain temperature, and in this column, this reaction is going to take place, and we're going to put steam in with a reboiler and give it energy. Then what happens then, once that process has been finalized, it then goes to mechanical engineers, and mechanical engineers aren't that bad, really. I do love them, okay? And the control and instrumentation guys, and they put a design envelope around that design intent. So they'll give you a design envelope, and that's expressed on the P&IDs. So we define the design intent and how this operates. How are these instruments that we refer to controlling the process? Then once we've defined that design envelope, it then comes to me, process safety. Our job is to look at deviations from design intent. What if that instrument doesn't work? So we we specifically, having defined the design intent and the control, we systematically go through a HAZOP, which can be a very systematic, laborious process, and say, what if that level controller fails? And we then might protect it with another instrument, but that is then your independent layer of protection that has to be, that's your trip or your interlock that I talked about, and it must be independent. It's no good saying, well, we're going to take it off the same level instrument, but it's a separate valve, because then your problem is that the level instrument has failed to control the valve, and now you're relying on that instrument to be part of your solution. You can't do that. It's like kissing your sister. It might work, but it's not right. Okay, so that's one thing I talk about to get over in people's minds. Okay, so it must be independent, and that's how the process goes through, systematically identifying what's independent. Now, what we must bear in mind is that trip itself is only an instrument, and it's only right in its right. So it's also got a degree of failure, and there are different degrees of integrity of the instrumentation, and we call that a safety integrity level. So a very important trip that's buying you a lot of safety is going to be very expensive and quite complicated, and then a small trip that's not buying you a lot of safety will obviously be commensurate with the risk, will be less complicated. So the degree of protection that you're buying with your instrument depends on the intricacy of the design. So it's not just a case of sucking your thumb and putting an instrument in there and a layer of protection in there. There's a certain amount of science behind it as well. But in general, we prefer the instrumentation.
Thank you, Martin. Thank you all. I'm aware of the time, and we need to wrap up. We've got a couple of questions that have come up on the chat. I expect that Leena and her team will gather those and share them with the Sasol colleagues, and if they can provide some guidance a little bit later, then they'll be able to do that as well. Once again, a really big thank you from, especially from my side, to the colleagues from Sasol that's come through, presented here today, provided some really useful information, and I think the students have really enjoyed both presentations that we've had. I want to also remind the students that this is part of the series of industrial talks that the college is hosting. Please have a look out for the next invitation. Please attend, participate, ask questions. It's only through this process that you're going to learn more about the industry in which you are eventually going to serve. I'm now going to hand over to Leena for the close.
Okay, thank you so much, David. You basically summed everything up and perfectly reminded everyone of the next industry talk. But before I go there, I just want to thank all my colleagues from Sasol. Thank you very much for taking the time to come and speak to our students. We will give you all feedback from the session via email, including recording. So once again, thank you everyone. And I look forward to seeing you all at the next tech talk happening, or industry talk happening on the 15th of September, hosted by CSIR. Thank you everyone, and goodbye.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.